Hey guys, today we're going to put some exponent examples into our journal. So we're going to go ahead and start in our table of topics, and this is going to be the fourth topic, and we're just going to call it exponent examples. And today's date is going to be the 16th. Alright. We're going to start off really simple and just do some basic ones, and then we'll work up into some harder ones. So the first one I want you to do is m cubed times m squared. M cubed times m squared. When you have like bases that are being multiplied, you're going to add your exponents. So it's going to be m to the 3 plus 2 power. Like bases that are being multiplied, you add your exponents. And then 3 plus 2 is 5. Okay, here's one for you to do. 3 to the 4th times 3 cubed. 3 to the 4th times 3 cubed. Okay, I want you to go ahead and pause now and work this problem. Okay, again here you have like bases that are being multiplied. When you have like bases that are being multiplied, you add your exponents. So you keep your base the same, and then you add your exponents. So 4 plus 3. 4 plus 3 is 7, so 3 to the 7th power. Okay, the next example. Okay, you're going to have 5 squared times 10 squared. 5 squared times 10 squared. In this case, you do not have the same base, but you do have the same exponent. So with your big numbers or your bases, you're going to go ahead and do whatever operation is there. So you'll go ahead and multiply it. So you'll say 5 times 10. You multiply your bases, and then you just keep the exponent the same. And then 5 times 10 is 50, and then you keep the exponent squared. Here's one for you to work on. We're going to do 3 to the 7th times 12 to the 7th. I want you to go ahead and pause now and work on this problem. Okay, again with this one you have different bases but the same exponent. So you're going to go ahead and do the operation here that has multiplying the bases. So 3 times 12, and then keep the exponent of 7. So 3 times 12 is 36. And your exponent will stay the same as 7. Okay, the next one, we're going to do c to the 8th divided by c cubed. We're going to write this out so that you can understand why this is happening. We know already that when we have like bases that are being divided, that we subtract them, but we're going to go ahead and look at why this actually works. So here if we have c to the 8th, that's like saying c times c times c times c times c, 1, 2, 3, 4, 5, times c times c, 1, 2, 3, 4, 5, times c. And then in the denominator we have c cubed. That's like saying c times c times c. Well, c over c is just going to equal 1. So those are going to cancel out. And then we have two other groups here that we can cancel out. These C's are canceling out, and these are canceling out. And then how many C's do you have left? Well, you have 1, 2, 3, 4, 5. That's the same thing as saying, okay, well, C to the 8 minus 3 power, and 8 minus 3 is 5. So C to the 5th. You can just skip to this step when you're doing your work, but I wanted to just show you here why it is that it's working, because they're canceling out. Okay, here's one I want you to try. 5 to the 6th divided by 5 squared. Go ahead and pause now and work on this problem. Okay, again, we're going to go ahead and write this one out. I want you to know the shortcut and know the rule for it. So not every time that you do this will you need to write it out like this, but just in our notes, we're going to write it out so we see why it works. So 5 to the 6th would be represented by writing 5 being multiplied 6 times. Okay, and then in the denominator it's 5 squared, so it's going to be multiplied 2 times. 5 over 5 equals 1, so that one cancels out. 5 over 5 equals 1, it cancels out. How many are left? 4. It's the same thing as saying 5 to the 6 minus 2 power, or 5 to the 4th power. Okay, here we're going to look at power to a power. So we're going to have C to the 6th power, all raised to the 4th power. Again, it's like the distributive property. Whatever is inside, you have to multiply it to each exponent. So in this case, there's only one exponent. So C to the 6th to the 4th power, you multiply it. So C to the 6 times 4 power. 6 times 4 is 24. So C to the 24th power. Okay, here's one for you to work on. It's going to be 19 squared to the 3rd power. Go ahead and pause it and you do this one now. Okay, again, this is a power to a power, so that we know that we're going to multiply this. So our base stays at 19, and it's going to be to the 2 times 3 power, and 2 times 3 is 6. Okay, this one is power to a product, so we're going to have more than one thing inside the parenthesis. So we'll say 9z squared b cubed. That's a squared and that's a z. All to the 5th power. Now in this case, again, it's just like the distributive property, but you're going to have to distribute it to everything inside the parentheses. So the exponent for the b is a 3, the exponent for a z is a 2, but here, when there's not an exponent listed with the 9, it has an exponent, but when nothing is listed, you have to know that there is an exponent there, and it's a 1. So if you need to, go ahead and add a 1. If you see it, that's great. But you're still going to have to distribute the exponent to every other exponent inside of the parentheses. So it's like saying 9 to the 1 times 5 power, z to the 2 times 5 power, and b, and these are all being multiplied, and b to the 3 times 5 power. So 1 times 5 is 5, so 9 to the 5th power, and then z to the 2 times 5, 2 times 5 is 10, so z to the 10th power, and then 3 times 5 is 15, so b to the 15th power. Okay, now I'm going to give one for you to do. We are going to say 6 times p squared times a to the 4th all to the third power. You go ahead and pause it now and work on this one. Okay, again, you're going to have to distribute this 3 to everything because it is a product of a power, so the power is distributed to every exponent here. But again, this factor here isn't showing an exponent, so what is the exponent that's there? If there's not one listed, it's a 1. And it has to be distributed there also. So you're going to have 6 to the 1 times 3 power, p to the 2 times 3 power, and a to the 4 times 3 power. Well, 1 times 3 is 3, so 6 cubed. And then 2 times 3 is 6, so p to the 6th. And then 4 times 3 is 12, so a to the 12th. Okay, we're going to go ahead and turn the page over now, and we're going to work on some multi-step problems. These were all pretty basic problems, and we're going to take all of those things and we're going to apply it into some more in-depth problems. Okay, so the first one that we are going to look at is, this will be number 11, and it's 7 to the 4th times 7 cubed over 7 squared. So 7 to the 4th times 7 cubed all over 7 squared. You let it focus. Come on. Okay. So we have to have one numerator, or one base and one exponent in the numerator before we can continue on to simplifying this. So we can simplify the numerator first, and we're able to say, okay, well, these are like bases and they're being multiplied, so I know that I need to add my exponents. So we're going to have 7 to the 4 plus 3 power, but then our denominator stays the same as 7 squared. Alright, so 4 plus 3 is 7, so we have 7 to the 7th power divided by 7 squared. Now here, like bases that are being divided, so we know that we need to subtract our exponents. You might also have heard it as stacked, then you subtract. So we keep our base the same, and we just subtract our exponents. So 7 minus 2. 7 minus 2 is 5, so the answer would be 7 to the 5th power. Now, guys, this is just a two-step problem, so we just added one more step to it, but it's still using the same exponent rules. Okay, here's one. I want you to try this one. It's 4 to the 6th divided by 4 squared to the negative 2nd power. Before you start working it, I want you to think about, is the numerator a single base and a single exponent? It looks like it to me. What about the denominator? Is that a single base and a single exponent? It's got 2 exponents here, so we need to go ahead and simplify that. I want you to pause it now and go ahead and simplify that. Alright, so you should have noticed that it was a power to a power in the denominator. So when you have a power to a power, you know that you need to multiply it. So 2 times negative 2 is what you would do. What is 2 times negative 2? It's negative 4. So we have 4 to the negative 4th power. And now this is a simple problem because we know when we have like bases that are being divided that we need to subtract the exponents. So we would say 4 to the 6th minus negative 4. This is where knowing our integer rules comes in big. 6 minus negative 4. Minus a negative is the same thing as adding a positive. We could look at it as keep, change, change. So it would be 6 plus 4. So our exponent is going to be 10. So it's 4 to the 10th power. 6 plus 4. Keep, change, change. So your answer is 4 to the 10th power. Alright, this next one that we're going to look at is one like we've already done. It's just written a different way. So you're going to have 7 to the 8th power times 7 to the 5th power, and instead of using the fraction bar like we did with number 11, we're just going to say divided by 7 to the 10th power. So again, if you're thinking about order of operations, you know that you have to start from the left and work your way right. You can't just go ahead and divide these. You need to go ahead and simplify it here and then divide it out. So simplify this just like you did on number 11. So you go ahead and do that now. Okay, so you should have noticed that it was like bases being multiplied, so you need to add the exponents here. So you should have said 7 to the 8 plus 5 power, and then it's going to be divided by 7 to the 10th power. 8 plus 5 is 13, so it's 7 to the 13th power divided by 7 to the 10th power. Well, again, guys, this is a simple one-step problem here. We know that get that out of the way. We know that they're like bases being divided, so we know we have to subtract our exponents. 7 to the 13 minus 10 power. 13 minus 10 is 3. 7 cubed, or 7 to the 3rd power, is your answer. Okay, number 14. I want you to try this one on your own. It's going to be 7 to the negative 8th power divided by 7 to the negative 11th power. Do not let the negatives scare you, and remember your exponent rules. Go ahead and pause it now and work on this one. Okay, we have like bases being divided, so we know that we have to subtract our exponents. So you have 7 to the negative 8th minus negative 11. All of these negatives look a little scary, but you know that when you're subtracting, you have to do keep, change, change. So you would say, okay, negative 8 stays the same. A subtraction sign becomes an addition sign, and the negative 11 becomes a positive 11. Now we just have unlike signs being added, so you're going to take the sign of the larger absolute value. That's going to be 11, so it's going to be a positive exponent, and then you're just going to subtract it. So 11 minus 8 is 3. So your answer is going to be 7 cubed. Okay, and the last one that we're going to look at, I'm going to tell you in this one that m equals negative 7. We're going to have to plug this in to the problem. The problem is c to the negative m power divided by c to the m power. Well, we can obviously tell that one of them's m and one of them is the opposite of m, or the negative of m. We have to plug this in, and anytime you plug a number in or substitute a number in, you have to put parentheses around it. So instead of writing an m here, we're going to just put parentheses around negative 7. Now I can't get rid of this negative because this negative here and this negative are totally different. So we're going to keep that negative, but we're also going to input a negative 7 or substitute out a negative 7 where the m once was. And then we're going to do the same thing on the bottom. We're going to have a c, and then instead of an m, we're going to put in a negative 7. Alright, so here the negative of negative 7, or negative 1 times negative 7, is a positive 7. So you have c to the positive 7th power divided by c to the negative 7th power. Again, I just want you to see you have a negative and a negative. A negative 1, if you will, times negative 7. So negative 1 times negative 7 equals a positive 7. Or negative times a negative equals a positive. Now this is a simple one-step equation or one-step power rule that you have to use here. You have like bases that are being divided so that you know you need to subtract them. So you go ahead and subtract them now. Alright, so you have a like base of c, and you're going to say 7 minus negative 7. 7 minus negative 7. Minus a negative, you can automatically say, okay, minus a negative is the same thing as adding a positive. Or you can look at it as keep, change, change. So 7 plus, so keep, change, and then negative 7 would become a positive 7. Well, what is 7 plus 7? It's 14. So c to the 14th. Okay, so I hope this gives you a little extra practice and a look at some of the more multi-step exponent rules problems.